Algebra 3, Lesson 8, starting on page 61. The things that this lesson deals with are statements of similarity. What does it mean if two things are similar? Same what? Same shape, different size. Can you tell me anything else about similar figures? What's true about their angles? Angles are congruent, sides are, what do we know about their sides? Sides of similar figures are what? Proportional, okay? So those are some things that if I didn't already know them and didn't have them off the top of my head, I'd want to write down. Similar figures, same size, different shape. Angles are, corresponding angles are congruent. Corresponding sides are proportional, right? And proportions, hopefully we know how to set up proportions, so that's going to give me more information. Okay? Now, some of these, I'm going to kind of skip ahead in the book to explain little parts of why some of these things work, because math is interconnected. Stuff that shows up here will show up later down the road. Some of the stuff that shows up later down the road, though, helps, I think, understand some of this a little bit better, too. All right, other things that we see in here are proportional segments, okay? We've already kind of addressed that with statements of similarity. And then we're going to deal with something separate, which is an angle bisectors and side ratios. So just real quick on angle bisectors, what does it mean to bisect something? Cut it in two equal parts, right, to bisect it. I think that's maybe, cutting it in half is a good way of saying that, but I want you to understand that both sides are equal in length, okay? So if we bisect an angle, what we're saying is that we have a whole angle, we're dividing it in two, so the two separate angles that make up the whole angle have the same degree measure, okay? All right, and then we're going to talk about side ratios based upon angle bisectors. All right, so the first question that we get up here is we know that triangle DLW is a right triangle. DLW, that's the big triangle that you see here. KC or CK is perpendicular to LW, which tells me that there's another right angle, okay? We want to outline a proof that shows that DW, okay, that is the hypotenuse of the bigger triangle, over LW, that is the base of that triangle, is equal to the ratio of CW over KW. So basically, this is a lot easier than it really looks when we start talking about proofs. If you had geometry, proofs are pretty daunting. This one, they start off pretty easy. In fact, amazingly enough, our Algebra 3 proofs, I think, are easier than your geometry proofs. None of your proofs, if you get a proof on a test, none of them are very long. They usually can be solved in about 4 steps. Okay, that's really not too bad. In fact, this is even in such a case where because of this being the way that it is, this is what I want you to see is here I have this triangle, and here I have this triangle. They both have a right angle, right? Okay, so they're right triangles. Let's see, and angle W is shared. Okay, angle W is shared. So what do I know about angle D and angle C? Does anybody know? What do I know about angle D and angle C? How do you know they're congruent? I hear people whispering things. Okay, Draven's got his hand raised. How do I know that they're the same? How do you know they're similar triangles? Okay, let's go back. What are these two shapes? They're both triangles, okay? Do I know anything about the angle measures or the sum of the angle measures of a triangle? 180 degrees, right? Now, we already know that these two are 90 degrees, right? All right, do you understand what I mean whenever I say that angle W is congruent to angle W? You notice how they both triangles share angle W, right? So it really doesn't matter what it is. They share it. It's the same in both, correct? That's what we call the reflexive axiom. Okay, is whenever angle W is equal to angle W, reflexive axiom. Okay? So that's the same. So if we said X, if I knew what angle W was, right? If I knew it was 17, then I would know it was 17 on both, right? Okay, so if we have what, 107 degrees spoken for, correct? All right. Then would angle D and angle C both have to be the same thing? Why? Because there is a limit. There is an exact limit to every triangle. There's an exact maximum, there's an exact minimum, and it is the same thing in every single triangle. What is the limit for degrees in a triangle? Can I have less? Can I have more? It has to be that. Okay? So this is something that we learn at some point, is that if I know two angles, okay, then I know all three. Okay? So if two angles of a triangle are congruent to two angles of another triangle, then the third angle is congruent. Okay. So now have we proven that all three angles are congruent to each other? Okay, so I've got two triangles. All three angles are congruent. So what have I proven about these two angles? They are what? Similar. They're similar. So basically, if I'm going to prove that two triangles are similar, I have to prove one of two things. Either all three of their angles are congruent, or all three of their corresponding sides are proportional. We used angle, angle, angle similarity postulate. I know that we're not there yet in this lesson, but I want you to understand how we get there. Okay? All right. So because of that, we know that triangle DLW is similar to triangle CKW. And whenever I write a similarity or a congruent statement, do I have to put corresponding points with corresponding points? Okay, so D corresponded to C, L corresponded to K, W corresponded to W. We understand that. Okay, so because these two triangles are similar, then they are proportional. Okay? Questions? All right. But you see how I got to say that they were proportional first. Okay, I gotta prove that they're proportional first. All right, so let's come down here. Do we have enough of that down that we're good to go? Okay. Whatever you missed will be in the video. All right, let's come down to number 2. We got a lamppost. It's 6 feet high. It's the little guy down here. Casts a little 8-foot shadow. At the same time of day, we got a flagpole. That's this big guy right here. Directly behind the lamppost, he casts a 28-foot shadow. Which proportion can be used to find the height h of the flagpole? We're not even trying to solve the question. We just want to know which proportion would work. Well, let's just do this for now. What kind of proportion would you set up to solve for h, Katie? H over what? H over 28, okay, equals what? What? 6 over 8. Okay, because you're doing this over this, then I need to do this over this. Okay, does that make sense? Corresponding sides it's got to match. Okay, now you could have done h over 6 equals 28 over 8. It all would have boiled out the same way. Let's see, do we have anything that kind of matches any of this? A, right? We see A, and really it's not any different. It's just kind of flipped, but it's the same thing. Okay, it would still give me the same answer. All right, number 3. Given that PQ is parallel to BC. We want to find the measure of AP. So that guy right there. Okay? So, are these two triangles similar? We know that they're not congruent, right? We know that they're not congruent. Okay, but are they similar? How do you know? Are all triangles? All triangles are similar, man. They're all similar. They're all proportional. Those two things, basically the same thing because they're both triangles, right? Fair enough. No. Okay, so I got a little triangle inside a big triangle. Let's see if I can create a triangle with another triangle in it that is not similar to the big triangle. So there's a little triangle, right? Inside a big triangle, and they're not similar. I have no guarantees. Okay? All right. The hint is that these two lines are parallel. So for those of you that haven't had geometry, I'm going to say this, you'll get into this in lesson 12. Two parallel lines cut by a transversal. Okay? Have corresponding angles that are congruent. How many of you that have geometry remember that? Okay? Good. All right, so here what I have is I have two parallel lines cut by a transversal. So these two angles are corresponding, therefore they are congruent. I also have two parallel lines cut by a transversal, therefore these two angles are congruent. I also have a shared angle, right? And those angles are congruent. So I have three corresponding angles congruent to three corresponding angles. Are those two triangles proportional? Okay? That is only true because those two lines were parallel. Does that make sense? It's kind of jogging some geometry mind for you. Okay? Again, you'll get into that later and more specifically. Okay? But this is an important thing to get with these proofs. Okay, so we know that these two triangles, now we know that they're similar, which means side lengths are proportional. So if I want to find this, you know, here's this triangle, here's this triangle, correct? We don't know what this is. We know this is 6. We know that, what is this length right here? What's this length right here? Is it 12? It's 18, good, because we've got to add all that up. 18. All right. And what is this side over here? 8 plus x. Okay, so can we set up a proportion? Okay, Michael, what's the proportion you want to set up? 18 over 8 plus x. 6 over what? Okay, so you did 18 over 8 plus x, so you need to do 6 over x. Okay? All right, now what? Cross multiply, so I got 18x. That's the easy one. Right? What's next? 6x plus 48. Okay? What's next? Okay, subtracting 6x. Okay, 12x equals what? 4? How about 48? What? X equals 4. Okay, and so AP equals 4, correct? Okay. There's a little bit of an easier way, but I'm not going to tell you what it is. X over 8 equals 6 over 12. Anyway. Okay. Let's see. I want to actually get down to number 5, because what's funny about number 4, as you'll notice, all they do is it's all the same thing, except we're just missing this part. With it's the same numbers, then we know that PB is going to be 8, right? So it doesn't really do us a whole lot of good to do that. All right, so this is what we learn about in 5 and 6, is that if I have an angle bisector, all right, actually turn in your book real quick to, so what you saw, the questions here, that is section 8.B, proportional segments, and I give you several examples of that and a little bit quicker ways to do it. But now we're at 8.C, which is angle bisector ratios. So the first thing I would do is, as you come in here, because it's telling me that this is a bisector, I'm going to put in the angle, I'm going to put in the length measure. So this is 9, DB is 11, AB is 13, and I'm going to solve for this. Okay, so we're dealing with these triangles, but again, we're setting up proportions. So actually, let's do this. Let's call this 9 and x. Okay, so I can do x over 9, but if I do that, what do I need to do on the other side? Does anybody know? 13 over 11. Very good. Now, there's a couple of different things I could do. Like, I could do x over 13 equals 9 over 11. Okay? But I can't, I don't want to cross them up. Okay? So if I'm going to do this triangle over this triangle, then I need to pick corresponding sides over on the other end. So I should get, what, 11x equals, some stuff here, or, hold on. Yeah, 11x equals 117. So x equals what? Should get a decimal. 10.64, right? Okay, so keep that in mind. My answer can come out as a decimal. Okay, that doesn't mean that I did it wrong. What I want to see if you guys can do is I want to see if you guys can solve number 6 on your own. And it will also be a decimal. Of course, you got a list of possibility answers down there. All right, so at this point, I'm going to hit stop on the video. I'll let you guys finish that question.